Hello and welcome everyone. This is Mohammad Inzamam from Saimedha Ecet Coaching Center, Koti, Hyderabad. Saimedha Koti, Hyderabad is providing free of cost YouTube video lectures for previous Ecet examination questions from the effective faculties of Saimedha Koti, Hyderabad. My dear students, in these video lectures every single day for all the branches EC, EEE, Mechanical, Civil and Computers. For all the branches every single day we are updating PYQs, previous Ecet examination questions. So what are you waiting for, guys? Subscribe the channel and press the bell icon to be notified for the further more updates. Daily update చేస్తున్నాం. My dear students, in the era of where people are making everything as a business, Saimedha Koti Hyderabad is giving the coaching for online Ecet 2024-2025, offline Ecet 2024-2025 కి మనం కోచింగ్ అనేది న్యూ అడ్మిషన్ న్యూ బ్యాచెస్ అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈ రోజుల్లో where 10th class admissions are going to be for month, effective faculties లో home tuitions కూడా పర్ మంత్ ఎవరైనా సరే 1000 రూపీస్ కంటే తక్కువ అంటే ఛార్జ్ చేయడం చాలా కష్టం. ఎఫెక్టివ్ ఫ్యాకల్టీస్, రెప్యూటెడ్ ఇన్స్టిట్యూట్స్ లో రెప్యూటెడ్ ఎక్స్పీరియన్స్డ్ ఉన్న ఫ్యాకల్టీ మెంబర్స్ తో మీరు 10th క్లాస్ హోమ్ ట్యూషన్స్ తీసుకోవాలన్నా సరే పర్ మంత్ దే విల్ బి డెఫినెట్లీ ఛార్జింగ్ మినిమం 1000 రూపీస్. అలాంటిది in and around for 1 year you will be getting a payment of around how much? 12,000. For SSC home tuition itself, if you are paying 12,000, guys, Saimedha Koti Hyderabad is providing 1.5 year coaching, 2 years coaching, 3 years coaching. Saimedha Koti Hyderabad lo coaching anedi first year diploma nunchi start అయిపోయినాయి, second year diploma students ki start అయిపోయినాయి, third year diploma students ki start అయిపోయినాయి. 3 years course ఉంటది, 2 years course ఉంటది, 1 year course ఉంటది. అలాంటిది టోటల్ కోర్సెస్ కూడా ఎప్పుడు మన దగ్గర ఫీజు అనేది 10,000 దాటలేదు. అందులో కూడా మళ్ళీ మెరిట్ పెట్టి పర్సెంటేజెస్ వైజ్ కన్సెషన్స్ పెట్టి ఎకనామికల్లీ బ్యాక్వర్డ్ ఎవరైతే ఉంటారో వాళ్ళని ఎంకరేజ్ చేయాలనే ఉద్దేశంతో మినిమం ఫీజెస్ తో మాక్సిమం కన్సెషన్స్ తో సాయిమేధ కోటి హైదరాబాద్ ఈస్ ప్రొవైడింగ్ ఎవ్రీ ఇయర్ కోచింగ్. రిజల్ట్స్ విషయానికి వస్తే యు నో ఇట్ గైస్, ఎవ్రీ సింగిల్ ఇయర్ టాప్ 5 బ్రాంచెస్ లో స్టేట్ ఫస్ట్ ర్యాంక్స్ తో పాటుగా మాక్సిమం ర్యాంక్స్ వాస్ సెక్యూర్డ్ బై సాయిమేధ కోటి హైదరాబాద్ ఓన్లీ. So my dear students, what are you waiting for? Ecet 2024, Ecet 2025, Ecet 2026 coaching has been started in the Saimedha Koti Hyderabad. Effective coaching ఎక్కడైనా ఉంది, మనకు ఎక్స్పర్టైజ్డ్ ఫ్యాకల్టీస్ నుంచి ఎక్కడైనా కోచింగ్ ఉంది, డిజిటల్లీ రికార్డెడ్ వీడియో క్లాసెస్ ఒక సిస్టమాటిక్ ప్యాటర్న్ లో కోచింగ్ వీఆర్ ప్రొవైడింగ్ బోత్ ఆన్లైన్ అండ్ యాజ్ వెల్ యాజ్ ఆఫ్లైన్. సో వాట్ ఆర్ యూ వెయిటింగ్ ఫర్, గైస్? Download the app saimedha.in and press the bell icon to be notified for the every updates. Every single day we are going to be updating in the YouTube channel. Subscribe the channel, press the bell icon to be notified, download the app saimedha.in and scrolling on the mobile numbers ki contact journey and join now in Saimedha Koti Hyderabad. At the end of the video I'll come back one more time for some more information. Till then, guys, watch the video now.
And next one, let us solve question number 29. The copper brushes in the DC machine are used to the low voltage and high current, and next involved where high voltage and small currents are involved, where low voltage and low currents are involved, and where high voltage and the high currents are involved. So now this copper or carbon brushes, copper or the carbon, this carbon brushes are the used per small rating. This one is the small rating of the DC machine. The small rating of the DC machine means, so that is a low voltage, this one is a low voltage and high current application. So this one is high current applications point of view. So that answer for this question, option the one is correct, the low voltage and the high current rating. So but carbon is prepared as compared to the copper because of their self lubricant nature. So now also one more question, the electrographite, this electrographite brushes are used. So electrographite for the normal rating of the machine, normal rating, and copper graphite, this copper, the graphite for the large rating of the machine, the rating of the DC machine. These are the 3 type of the material used for construction of the brushes. So for small rating, copper or carbon, especially copper is used for the low voltage and high current application. So option 1 is correct. And next one, question number 30. 2 generators A and B have the 6 poles each. The generator A has wave wound, generator A has wave wound armature, while generator B has lap wound armature. The ratio of the induced EMF, the generator A and the generator B. So we require the generated EMF of the A generator divided by generated EMF of the B generator. So it is that this value is required. Okay. Now let's see first one for generator A. Okay, generator A. So this one is a generator. The A. Okay, this is the generator A is connected in the wave. So now this one is the wave winding, so that the number of the parallel paths, okay, A is equal to the 2 only. So generator B, so which is connected in the lap winding, so number of the parallel paths, the A is equal to the P. So how many number of the parallel paths? The 6 number of the parallel paths. Why? Because number of poles are equal to 6 number of the poles. So we know generated voltage, okay, in this case we know the formula to find out the generated voltage. What is the formula here? The EZ is equal to, okay, EZ the equal to 5Zn by 60 into P by A. So by using this during the designing, okay, this one, the during, okay, designing of the machine, so we get the generated voltage, okay, inversely proportional to the number of the parallel paths. Okay, generated voltage is inversely proportional to the number of the parallel. So we required A, okay, generated A, that is a wave. So divided by generated B is the lap connected armature winding. Very careful to select. So generator A is always wave connected armature. Generator B is a lap connected armature winding. So now this one, the generated voltage, so in the A, so that means lap, okay, in case of the wave, so divided by, okay, generated voltage, the B, so it is a lap connected armature winding. Now this is equal to inversely proportional, so that number of parallel paths in the lap, okay, divided by number of parallel paths in the wave connected armature winding. How many number of parallel paths in the lap? Okay, that number of parallel paths is equal to the 6 number of the parallel paths. Number of parallel paths in the wave winding, 2 number of parallel. Now this is equal to 3 by 1. So answer for this question, the 3:1 is the right answer. So that option, the 2 is correct for this question. And next one, the question number 31. The commutator segments are insulated from each other using option 1 mica, option 2 wood, and option 3 paper, and option 4 is glass. So my commutator segment, suppose, so this is assume as it is a C1 commutator segment, and it is a C2 commutator segment, and C3 commutator segment, and so on. So this is a insulation, okay, this part. So this one, okay, this part is a, so this part is a insulation, okay, between the insulation between the 2 commutator segments, okay, these 2 commutator segments. Now what is the name of this insulation? Always it is a mica insulations. Mica insulation is used between the 2 commutator segment. So that answer for this question, option 1 is correct. And the next one, question number 32. Field winding is connected across the armature winding. So now in this case mention that 6 pole wave wound armature winding. So that's number of poles in the machine. The 6 number of the poles. So 6. And number of the poles in the wave winding, 2 number of the poles. How many conductors are there? Over Z, the Z is equal to 300 number of the conductors. And what is the flux per pole? Flux per pole is equal to the 20 milli, pi is equal to 20 milliwebers, 20 into 10 to the power of minus 3 webers. And when runs at the 1000 RPM, so N is equal to 1000 RPM. And we require the generated voltage of the generator, the easy one. So we know how do we find out this generated voltage. So generated voltage of the generator, the easy is equal to, okay, this easy, the 5Zn by 60, the into P by the A. So this generated voltage easy is equal to, what is the value of the flux? The flux is equal to 20 into 10 to the power of minus 3, and number of conductors is equal to 300 number of the conductors. And this is a number of the speed of the machine, the speed is equal to 1000, so divided by 60, and number of poles is equal to 6 number of the poles. The number of parallel paths is equal to 2 number of the parallel paths. So this 1000 and this the 1000 and the 1000 will be cancelled out. Okay, 1000 and 10 to the power of minus 3 multiplied by 10 to the power of 3, and this one is a the 20 multiplied by 3. So this is the, and this is a 3 times. Okay, 3 also 3 will be cancelled. So what is the answer? Generated voltage EZ is equal to the 300 volts. So option the 3 is correct for this question. And next one, let us solve question number 33. Under peak load condition, the flywheel gives a part of kinetic energy, the torque required to be supplied by the motor. So now always, okay, let's Tm is a, so this one is the Tm, okay, it is a motor torque, the motor driving torque, okay, this one is the driving torque. So next one, the flywheel torque, Tfw is a, the flywheel. So this is the flywheel, okay, torque of the machine. And next one, the TL is a, okay, this is all the TL, okay, this is a TL is a load torque, okay, this load torque. Now this one is load torque is a opposing torque of the motor. So which is that load torque is imposed on the shaft of the motor. So which opposes the torque developed in the armature. So this one is opposing torque of the motors. Now always under steady state condition, so what will happen? So this is a, the always here driving torque is equal to, or the load driving electromagnetic torque, driving torque, okay, always this drive, the torque of the motor, okay, is equal to the opposing torque of the motors, okay, this opposing the torque of the motors. So what are the driving torque of the motors? The motor torque plus flywheel torque. So now that is equal to, okay, next one, the TL. So now this motor torque is equal to, so what is the answer for this question? The TL minus, okay, TFL. So now answer is, okay, TL minus TFL. So motor torque is equal to option 1 is correct for this question. Let us solve question number 34. A 4-pole lab-wound DC generator has 40 coils with 8 tons per coil. It is driven at the 1200 RPM. If the flux per pole is the 0.022 Webers, then the generated EMF is option 1 26.8 volts and option 2 276.3 volts, the 281.6 volts, and option 4 287.9 volts. Okay, and what is the given data in this question? Given that the number of the poles P is equal to 4 number of the poles. Armature is connected in the lab, so that number of the parallel paths the is equal to number of the poles, so it is equal to 4 number of the poles. And we required the number of the conductors. Directly it is not mentioned, 40 coils. So with the 8 tons per coil. So how do we get the number of the conductors? How many coils? We have a 40 coils. A coil has 2 coil sides. Okay, this is the 2 and 8 tons per coil. So that means 8 conductors. So this 40 indicates number of the coils, okay, in the armature. Now this 2 indicates coil sides, okay, this one is the coil sides per coil, okay, this one, and 8 ton coil means, okay, this number of the conductors. So this number of conductors per, okay, this is the number of the conductors per coil side. So like this we need to calculate the number of the conductors. So 40 indicates the number of the coils, the 2 indicates coil sides per coil, the 8 indicates, okay, number of the conductors per coil side. So now multiplied this. So now here this is a the 48, the 64, the 640 conductors. Okay, is that clear? So 16 and 64 conductors, 640 conduct, and also mention that N, the N is equal to 1200 RPM speed of the generator, and flux per pole is equal to 0.022 Webers. Okay, 0.2, and we required generated voltage of the generator. How do we find out generated voltage of the generator? So we know the formula to find out generated voltage. Okay, EZ is equal to 5ZN by 60 the into P by A. So this generated voltage, the EZ is equal to the flux per pole is equal to 0.022 and the number of the conductors is equal to 640 conductors and the speed is at 1200 rpm, the divided by 60, the number of the poles, okay, 4 number of the poles, and number of parallel paths also is equal to 4 number of the parallel paths. Now simplify this. So now this one is the 60, okay, 0 will be cancelled out, okay, 60 into, okay, 20 times, okay, 6, this is the 20 times and the 4 will be the cancel. So this generated voltage is equal to 0.02 multiplied by 640 multiplied by the 20. So now by solving this, this value is equal to 281.6 volts. So answer for this question 281.6 volts. So option 3 is the correct. And next one, let us solve question number 35. The Fleming's right hand rule. The direction of the induced EMF in the conductor is given by this one is a index finger, middle finger and thumb, and option 4 is a right finger. So now Fleming's, okay, right hand rule, okay, FRR. So direction of induced EMF in the generator can be obtained by using the FRR. So FRR means forefinger. So this assume as a forefinger and this one is the center finger and this is a thumb of the right hands. Okay, this is the thumb of the right hand one. So forefinger indicates, okay, direction of the flux and the thumb of the right hand, okay, indicates force applied on the conductors. So this one is the force applied on the conductors. Now center finger, or it is also called the middle fingers. Okay, this is the middle finger. This center finger indicates the direction of the induced EMF, okay, or induced current. So this is the unknown parameters. So if we know these two, so we can find out the unknown parameter, that is the middle finger indicates the direction of induced EMF. So that option, the 2 is correct for this question. And next one, let us solve question number 36. A lap winding is suitable for dash applications of the DC generators. Option 1, high voltage and the low current, the low voltage and low current, high voltage, high current, the low voltage and high current. So lap winding has more number of the parallel paths as compared to wave connected armature winding if poles are the more than the 2. So therefore the lap connected armature winding, so lap winding, okay, is used for always low voltage, okay, and high current applications, okay, this high current application. But now if it is a question about wave winding, then the wave winding is used for, okay, it is a high voltage, so high voltage and the low current application. So why? Because lap winding, in the lap winding, number of conductors per path are less as compared to the wave winding, but number of parallel paths are more. So that's why as the number of parallel paths increases, the current rating of the machine increases, and number of conductors per path, okay, decreases, the voltage rating of the machine is decreased. So that's why in case of the lap winding, so here this lap winding is used for low voltage and high current applications. So that option 4 is correct for this question. And next one, question number 37. A commutator in the DC generator can, statement 1, provide half wave rectification, provide full wave rectification, converts AC to the DC, converts DC to the AC, and provide the controlled full wave rectification. From these correct statements are, so here mention commutator in the DC generator, not in the DC machine. Suppose DC machine is given, we need to select. So motor and generator point of view, we need to select. So especially for generator point of view, so it converts the DC, in case of the generator, in the generator, so now here it converts AC to, okay, DC, act as a converter, okay, this is the first function. Now it provides the, suppose the current in case of the armature, this is the sinusoidal, in case of current in the armature and current in case of, or voltage or current, you can take this is the voltage also. Now this is this is the output voltage or output current, okay, the current in the load. So now this is nothing but the full wave rectification or the rectification pointer. So now it converts AC to the DC, but which again, so this is the provide the full wave the rectification only. So that's why commutator can be treated as the full wave, okay, uncontrolled. So this one is a uncontrolled, the rotating, okay, this, okay, rotating converter or rectifier. So this is a answer for this question. Now let us select in case of the rectifier. Provide the half wave rectification. This is the wrong statement. Full wave rectification, it is a correct statement. Converts AC to the DC, and this is also correct statement. Converts DC to the AC, it is a wrong. Provide control full wave rectification, it is a wrong. So that's why what is the answer? Which statements are correct? The 2 and 3 statements are correct. Option 2 is correct for this question. And next one, question number 38. A 4-pole DC machine has dash magnetic circuit. Option 1 4 and option 2 8, option 3 16 and option 4 2. So now a 4-pole DC machine has dash magnetic circuit. So this is a 4 number of the magnetic circuits. So option the 1 is correct for this question. And next one, question number 39. The poles are made up of laminated core because it reduces the option 1 eddy current losses and copper losses, option 3 frictional loss and option 4 hysteresis loss. So any magnetic material is laminated to reduce the eddy current losses. By laminating the material, conductivity of the core decreases. The decrease in the conductivity decreases the eddy current losses of the any magnetic material. So why? Because eddy current loss always directly proportional to the conductivity of the core. So by laminating the material, conductivity decreases. So where decrease in the conductivity decreases eddy current losses of the magnetic material. So that option 1 is correct for this question. And next one, if YB is a back pitch and Y is a winding pitch, then front pitch YF or YF for a progressive simplex winding is given by. So YF is equal to Y plus YB per lap winding, and YF is equal to Y plus YB per wave winding, and YF is equal to Y minus YB per wave winding, YF is equal to Y minus YB per lap winding. So here mentioned that's progressive simplex winding, but not given whether it is a lap or wave winding. So for progressive, this progressive, the lap winding, this lap winding. So now what is the winding pitch? YW is equal to YB minus YF, YB minus Y. Now from here we can find YF is equal to the YB minus winding pitch. W is a winding pitch, YB is a back pitch, and YF is a front pitch. So for the progressive wave winding, this progressive wave, the winding, so this progressive wave winding, the winding pitch is equal to YB plus YF wall. So YB plus Y, but we required YF. Then so this is the YF is equal to the winding pitch minus YB, the back pitch of the wind. So now let's verify one first the option. YF is equal to Y plus YB, the per lap winding. YF is equal to Y plus YB per the lap winding. This is the wrong statement. And YF is equal to Y plus YB per wave winding. YF is equal to Y is nothing but winding pitch. This is the winding pitch. So now YF is equal to the Y plus YB per wave. This is also wrong statement. Now next one, YF is equal to winding pitch minus back pitch per wave winding. This is the correct statement. And YF is equal to the winding pitch minus back pitch per the lap winding. So now this front pitch is equal to back pitch minus winding pitch. So this is also wrong statement. So now answer for this question. So this is a answer, option 3 is a correct for this question. So this question was given in the Ecet 2023 recently. So this was the discussion about previous year questions of in the previous year questions of Ecet in the concept of basic concepts of the DC machine, which is chapter 1. I hope you got it. Thank you very much.
So thank you very much guys for watching this video till the end. Definitely this video has been improvised your subject knowledge and definitely given you an idea about how the previous Ecet examination question is getting up here. Again one more time guys, ee video ni meeru nachite kachithanga like cheyandi, share cheyandi, subscribe cheyandi and press the bell icon to be notified for the further more updates guys. Admissions అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈసెట్ 2024, ఈసెట్ 2025, ఈసెట్ 2026 ఫస్ట్ ఇయర్ వాళ్ళకి, సెకండ్ ఇయర్ వాళ్ళకి, థర్డ్ ఇయర్ వాళ్ళకి ఆల్రెడీ ఈసెట్ కోచింగ్ అనేది ఆన్లైన్ కోచింగ్ అండ్ ఆఫ్లైన్ కోచింగ్ new batches is going to be started guys. So my dear students, what are you waiting for? Download the app saimedha.in. మీకు ఏ డౌట్స్ ఉన్నా సరే మన స్క్రోలింగ్ లో ఉన్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి. Join now in Saimedha Koti, Hyderabad. Thank you very much. This is Mohammad Inzamam signing off.